Hello my dear students, welcome everyone to India's first animated live tuition. I welcome all of you to 90 plus My Tuition app family. So you guys stay ready over there. Let's begin a brand new session. Please do revise all the portions which we have covered till now. I hope you remember we have covered the equations of motion in the last session. So we were solving some numerical problems, right? So I guess you guys have done the homework. I gave you a homework. That was about the turn, right? So how many of you have done the homework? Let me see. Everyone is like, sir, please don't start with the homework. We'll have fun. Then we'll begin the session. I know everyone is warming up over there. So in the meantime, before we go ahead, we'll start with what? We'll start with a tongue twister. We'll start with a tongue twister. In the meantime, those who didn't do the homework can get ready. I'm giving you an excuse. Okay, fine. So we can consume this 1-2 minutes for the homework, those who didn't do. But I won't tolerate in future. I hope all of my students are revising all the portions which we have covered. The thing is, we are going to step into a new topic, isn't it? If you don't have the concepts of equations of motion, what is the use of going ahead? Think about it. And do it for yourself. It's not something like, okay, just since the tutor instructed me, I'll do it. I'll go ahead with it. No, not at all. Got it? Fine. So we'll start with the tongue twister. Who is gonna give a tongue twister? Someone who wants to give a tongue twister. So can you please try it? Or we'll ask our students, we'll ask our friends to try it out. Who want to share something? Unmute down there, man. Shweta, man. Beside Ayman.
Okay. Hitanshi.
Hitanshi, yes, Hitanshi, you can unmute yourself. Hitanshi wants to share something. Yes, go ahead, Hitanshi.
Yes. So I would like to tell a tongue twister.
Yes.
Everyone should try it.
Yes, go ahead.
Okay. The tongue twister is so easy. Pake, paper, paka, papita, pinku, pakre, pake, papita.
Okay. So even I'm struggling to say it. Can you please type it down in the chat box so that I'll share it to everyone so that everyone can give it a try. Fine. Thank you, Hitanshi. A good try. I appreciate it. Then who else will call, guys? Let's be active. Show some energy. I don't want you guys sitting out there. Yes, sir. Please go ahead. We'll listen everything. No. Let's get ready. We are going to learn a new topic today. So a brand new session. Who want to share a tongue twister? Okay, we'll go with a simple one. So in the meantime, Hitanshi will be sharing it. The simple one. Who want to try it? Who want to try it? Go ahead.
Muhammad Shaheen.
Muhammad Shaheen. Yes, Muhammad Shaheen, you want to answer the homework question or you want to share a tongue twister?
I wanted to answer the homework question, but I'll try this.
Okay, you'll try this. Go for it.
Red ball, blue ball, 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 red ball. Yeah, that's okay.
Fair enough. Very good. Everyone give an applause. Applause for Muhammad Shaheen. Very good, Muhammad Shaheen. Fine. So let's go with the next one. She sells seashells on the seashore. Who wanna try it? Guys? So those who feel like, okay, I need to watch the session again, you want to recap, don't worry, this particular session is recorded live. So it's going on live in YouTube. Please do check it out as well. So please do unmute Mohammed Mas. Hi Mas, please do unmute yourself. Yes. So Mas, before we go, did you revise the concepts which you have learned till now? Yes.
Yeah.
You did, right? Then you can try. If you didn't do it, no, I won't give you a chance for fun. Not at all. If you didn't learn, if you didn't study, no time for fun. Fine. So Mas, which one do you want to try? The first one or the second one?
The second one.
Second one. Go for it.
So, it's she sells seashells
What's the seashore?
Mas, is this how you try the tongue twisters? You're supposed to try it in quick succession. Go for it. Quick succession. Go for it.
Okay. She said seashells on the seashore.
Yes. 5, 10 times. Minimum 5 times. Quick succession. Go
He
for it.
said seashells on the seashore. She 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 said seashells. What seashore?
Very good. Very good, Mas. I appreciate it. Any questions for me?
Can you study?
Okay. So Mas is like, sir, can you please try it? This one? Second one or the first one? Unmute Mas.
Sir?
Which one you want me to try?
The first one.
First one. Okay. How many times? 5 is fair enough, right?
No, sir. I think, sir.
Mars is like, sir, go for 50 times. Till the end of the session, we'll keep going ahead with tongue twisters.
I think since you're the adult here, you like 10 times.
Okay. 10 times we'll go ahead. Red bulb, blue bulb, 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 red bulb, blue bulb. Fair enough, right? So guys, over here we have Mihar sir as our host and Shweta ma'am, Mirin ma'am and Christy ma'am as our support tutors. So everyone is like, sir, so funny. Please, can you please stop it? So everyone is making faces, insulting me, mocking me, teasing me. Not good, right? The thing is, Mars has tried it in the best possible way. Yes, Ayman, go for it. Unmute Ayman. Ayman is like, sir, I just wanted to answer. Please don't give me tongue twisters. So which one you want to try, Ayman?
I'll try the red one.
Yes, go ahead, go ahead.
Red bulb, blue bulb, red bulb, blue bulb, red bulb, blue bulb, red bulb, blue bulb.
Good. Very good, very good. And some of you are sharing how much wood would a woodchuck chuck if a woodchuck could chuck wood. Fine. So some of you are sharing some interesting ones in the chat box. And mute Shweta ma'am, please minimize it. Yes. And mute Jagadish, right?
Yeah, Sanjit.
Sanjit,
Yeah,
yes.
Jai Ganesh.
Sanjit Jai Ganesh. Hi Sanjit, can you please unmute yourself?
Hi sir, how are you sir?
Yeah, I'm good. Thanks for asking. So Sanjit, have you revised the concepts which we learned till now?
Yes sir, I did sir.
You did, right? Do you remember the equations of motion?
Yes sir.
You do remember. Fine. Fair enough. Then you can try. Which one you want to try? The first one or the second one?
Sir, I will try the second one.
You want to try the second one? Go for it.
Seashells on the seashore, seashells on the seashore, seashells on the seashore, seashells
She said,
on the seashore.
she says seashells on seashore. Very good, very good. Sanjit, I appreciate it. So Tirtha is smiling. She is from the beginning of the sessions. Tirtha is like, oh, everyone is so funny. So let's give a try. Let's give a shot for Tirtha. Yes, Tirtha. Shoot your shot. Go for it. Give a try. Yes. Tirtha. Yes.
The second one.
Second one. Go for it.
She said on the seashore, she said on the seashore, she said on the seashore.
Fine. Fair enough. Very good. Fine. So guys, I hope. Yes, come again. Do you have any questions for me, Tirtha? Alright. Give me a thumbs up. Yes, sir. Can you please? Yes. Fine. So we'll go ahead. So, yeah. Who was that? So the tongue twister is Shweta ma'am. Please scroll here. So the tongue twister is this one. Okay, Hitanshi is sharing. Okay. Is that Hindi? Hitanshi is sharing a Hindi tongue twister. So I don't promote the regional tongue twisters. It's just that globally we will be following English, right? Some of you guys won't be familiar with Hindi. Anyways, since Hitanshi has shared it, I'll read it. Kache ped par pakka papeta, pakka pediya pakka papita, pakke ped ko pakde pinku, pinku pakde pakka papita. Fine. Fair enough. So thank you Hitanshi for sharing it. So let's go ahead, guys. Can we go ahead? I hope everyone has done the homework. So let's go ahead with the homework. I hope you are ready with it. So this particular question was the homework, right? A stone is thrown in a vertically upward direction with a velocity of 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? So this particular question, I gave you guys a hint, right? Mohammed Zuhair still sharing tongue twisters. Pad, kid, pod, curd, pull, cord. Okay, fine. Thank you, Zuhair. Zuhair is like, Zuhair will try this at the end of the session. Okay? So we'll go ahead with this particular numerical. So guys, initially when you get a numerical question, what will you do? Try to visualize. I told you guys, try to visualize it in your mind. So we are considering someone throwing a stone in a vertically upward direction. So this stone which goes up has a velocity of 5 meters per second. So initially it is having a velocity. So that is 5 meters per second square, 5 meters per second. That is the initial velocity. Now, at the maximum point, before the stone comes down, at the maximum point, it will have a particular velocity, right? That is 0. At the maximum point, the stone will be at rest before it comes down. So at the final point, the velocity will be 0. So the final velocity will be 0. We have discussed this already, but for those who missed the previous session, I am explaining it again. Is there anyone who just joined today? Anyone who just joined today? Alright, if there is anyone who just joined today, if it's your first physics session, what you have to do is, please do contact our admin team. What they'll be doing, if you request them regarding the chapter name or the sessions which you missed, they will be providing you with the links of the live sessions which you missed, so that you can cover up the portions which you missed. You will get the detailed explanations of the portions you missed. Got it, everyone? Clear? And also, in the session, if you have any query, please do raise your hand and ask me directly, or else drop your queries in the chat box. You have a support tutor as well. So guys, someone is there, new Rakshita, right? Rakshita Sane. Yes. Unmute Rakshita.
Yes, sir.
Rakshita, can you please tilt your camera a little bit down? And can you please remove the virtual background? We don't appreciate virtual backgrounds. It's just because if you go ahead with some backgrounds, tomorrow other students will be coming up with some other fancy background. Sanjit and Neha will be coming up with what we say, Captain America or Lamborghini car background in the background. So new pictures not allowed. So what you can do is you can blur your background. That's okay, but don't come up with fancy backgrounds. So Rakshita, you have to watch the live sessions which you missed. You have to cover it up, okay? You just joined today, right?
Yes, sir.
Did you attend the classes for any other subjects like biology or any other subjects? No, right? Fine. So if you have any questions during the session, please do raise your hands and ask me directly, or else you can drop your queries in the chat box. Clear?
Yes, sir.
Fine. Do you have any questions for me, Rakshita?
Not yet, sir.
Fine. So Rakshita is like, not yet. I'll come up with some more doubts. Fine. So guys, please do try it. So initially, what are we doing when we are visualizing? Imagine someone is standing over here. Okay? We are considering someone is standing over here. And if he is throwing a stone from a particular position to a particular height, imagine he is throwing a stone in the upward direction. So this is the maximum point. So at this maximum point, the velocity will be 0 meters per second. At the maximum point, the velocity will be 0 meters per second. Then at the minimum point, initially when he is throwing the stone, it has a velocity, right? It has a particular value, that is 5 meters per second. That is 5 meters per second. And when the stone goes up, there is something which is acting in the downward direction. That is none other than the acceleration due to gravity. That is, the acceleration of the stone during its motion is 10 meters per second square in the downward direction. What is this acceleration acting in the downward direction when the stone goes up? It's none other than the acceleration due to gravity. When we go ahead with the chapter gravitation, you will learn about the acceleration due to gravity in detail. I hope everyone knows that there is a gravitational force around us, right? So because of that gravitational force, there will be a particular term. There will be a particular physical quantity, that is the acceleration due to gravity. So that particular physical quantity acts over here, that is 10 meter per second square. So we are considering it as a rounded value, 10 meter per second square. Precisely it's 9.8. Anyways, so since this acceleration due to gravity is acting in the downward direction, we'll consider it as positive or negative. If we have to consider it as positive, give me a thumbs up. If we need to consider it as negative, give me a thumbs down. Everyone, to the camera. Thumbs down or thumbs up? Let me see. Thumbs down or thumbs up? Everyone knows that it is thumbs down. Why thumbs down? Negative. We are considering the acceleration as negative since it is acting opposite to the direction of motion. Over here, in this case, the stone is going up, right? We are considering a stone that is actually going up and acceleration is in the downward direction. So the acceleration A is equal to negative 10 meter per second square. Got it, everyone? So we got the initial velocity, that is u is equal to 5 meter per second. We got the final velocity, that is v is equal to 0 meter per second. So which are all the values we need to find out based on the question? We need to find out how much time will it take to reach there, and also we need to find out the height attained by the stone, which means how much height the stone is traveling from his hand to the particular maximum point. So this particular distance we need to calculate. This particular distance we need to calculate, that we can consider as s, right? That is the distance traveled by the stone. So we know the equations to find the time t and the distance or displacement s. So if you have the values a, u and v, can we find t? We can find t, right? If you have these three values, can we find s? We can find it out, right? Fine. So who is going to help me out? Who is going to help me out real quick?
I think Neha.
Yes, let's call Neha. Yes, Neha. Shweta ma'am wants to call Neha. Yes,
Yeah.
Neha. First
We have,
you're going to help me out to find the time t.
yeah.
Yes.
So we can use the formula V is equal to U plus 18.
We are considering the formula V is equal to U plus 80. I hope you guys remember the three main equations of motion. V is equal to U plus 80, S is equal to UT plus half 80 square, and 2AS is equal to V square minus U square. So we are considering the first one, that is V is equal to U plus 80. Fine. So we are considering the equation V is equal to U plus 80. So in this particular equation, we can substitute these three values, right, Neha?
Yes, sir.
So V is
0.
V is 0. 0 is equal to, how much is U?
5.
U is 5
minus 10t.
plus minus 10t into, how much is t? T is not there, right? So it is 10t itself. Fine. So 0 is equal to
5 minus 10t.
5 minus 10t. Then from this,
And then minus 10t is equal to
minus 10t will go to the other side. So 10t will be equal to 5. Then from this we'll get t is equal to 5 by 10. 5 by 10 means what?
1 by 2.
1 by 2, that is equal to 0.5 seconds. So 0.5 seconds is the value of time. Very good Neha, thank you. Then next we'll call, whom will we call? Shweta ma'am, to find out the distance traveled by the stone. We'll call
Rehan.
Rehan. Where is Rehan?
Yes, sir.
So Rehan, you wanna, can you answer how will we find out the distance traveled by the stone or the height of the stone?
So, we can use the second formula S equals UT plus 1 by 2 AT square.
Very good. We can use the equation S is equal to UT plus 1 by 2 AT square, and also we can use V square minus U square is equal to 2AS. If you substitute the values in that equation also, still you will get the answer. So using this equation, if you are trying to find out S, how will we solve it? S is equal to, how much is U?
U is 5 meter per second square.
U is 5, okay. U will be 5, not 0. So 5 into T, how much is T?
So T is 0.5.
0.5 into, not into, right? It's addition.
No, it's plus.
Yeah, plus 1 by 2.
It's 10 into 0.5 square.
Acceleration is 10. So we'll consider negative 10 or positive 10.
So negative 10.
It is negative 10, right? So negative 10 into how much is t square?
T square 0.5 square.
0.5 square. So understood till now? We are considering the equation ut plus half at square, and we are considering the values 5 into 0.5 plus 1 by 2 into negative 10 into 0.5 square. Why? Since t is 0.5 and acceleration is negative 10. And over here at the time we got the value as 0.5 itself, so we are substituting it, and we know the initial velocity u is 5 meter per second. It is given there in the question itself. I hope you remember. Fine. So in the next step, what will happen? S is equal to 5 into 0.5. How much will it be? It will be 2.5, right? Because 5 into 0.5 means 5 into 1 by 2. 5 by 2 is 2.5. So 2.5 plus 1 by 2 into minus 10 into 0.5 square. How much it is? 0.5 into 0.5.
0.25.
0.25. Very good. Very good. Guys, for such decimal multiplication, 0.5 square, you guys will be confused, right? What we'll do? If you're multiplying 0.5 into 0.5, you guys should make it very complicated, no, right? Just remove these two decimals. So two places we have to keep it reserved. And find out the answer. 5 into 5, if you do it, we'll get 25, right? 25. So in 0.5, one unit place is there. In the next 0.5, the next unit place is there. So we'll consider two unit places to the left. That is 1 and 2. So it will be 0.5. That will be the final answer. Remove the decimal, multiply it directly, and add the unit places for decimals. First unit, then tens, like that you can go ahead. So that you will get the answer easily. Fine. Thank you, Rehan. Then next we'll go ahead with S is equal to 2.5 plus half into, whom will we go ahead, whom will we ask? We'll ask Tom. Tom, yes. So negative 10 into 0.25, how much it will be? Come again? Come again?
Can I do it on a book inside?
Okay, you wanna check your notebook?
Yeah, I'm gonna do it on the notebook.
You didn't even try the homework, Tom? This question was the homework, right, Tom? Tom is like, sir, I didn't get time to try. Do it real quick. I gave you time in the beginning of session when we were into the tongue twisters. I told you guys, those who didn't do the homework, go ahead. So Shweta ma'am, please note Tom's name. Tom, the one final warning. I hope you remember in the previous session also I gave you a final warning, right? So this is the last warning. No final warnings anymore. You won't be forgetting about the homework in future. Fine. So please do minimize Shweta ma'am. Yes. We'll call Eric. Eric Joy on top. Yes, Eric Joy. Right and on top. Yes. So negative 10 into 0.25.
Negative 10. No, I came here to tell you that to find distance I used 2A's.
V square minus u square is equal to 2as. Yes, you can use that as well. But try this multiplication. 10 into 0.5. What do you have to do? Remove the two unit decimals and multiply 25 into 10. So you will get 250, right? In 250, just put two decimals to the left. So it will be 2.50. Understood?
Yeah, 2.5.
So,
negative 2.5.
yes, it will be negative 2.5. 2.50 is not required, right? Anyways.
Yes.
Understood? For 2.50, 2.5 is fair enough. So in this, how much we will get? S is equal to 2.5 plus 1 by 2 into 2.50. How much we will get?
1 by 2 into 2.5.
The half of 25 is 12.5, right?
Yeah, 12.5. Yeah.
So if you are considering one decimal to the left, it will be 1.25. Understood?
Yes, sir.
So it will be negative 1.25. So we'll consider 2.5 plus. Okay, we'll put a bracket. It will be negative 1.25. So 2.5 minus 1.25. How much will you get?
1.25.
1.25 itself for sure. So 1.25 is the height traveled by the storm. That is 1.25 meter. Did you get the same answer using the equation 2s is equal to v square minus u square?
Yes.
You got the same answer, right? Yes. Very good. Very good. Then those who tried
The other
it.
equation was much more shorter.
Okay, yes. 2as will be a shorter method. We'll try it. 2as is equal to v square minus u square. Yes, Eric, go ahead. 2 into
So then will become 2 into
negative 10 into
minus 10s
s is equal to
equal to 0 square minus 5 square.
okay. First we'll rearrange the equation so it will be much easier for you to solve it. So when we rearrange the equation, now what we'll do? We have to find out the distance s or the height s. So we'll keep the s over here. That is equal to v square minus u square divided by 2a. Can you do it? Because it is 2a into s, right?
Yeah.
2a into s, right? So for that, what are we doing? We are taking the 2a to the other side. We are taking the 2a to the other side. We'll write it more distinctively so that you will have a better clarity. 2a into s. So this 2a, we are taking it to the other side. So over here, the right hand side, it becomes division. So s is equal to v square minus u square. How much is v? V was 0, right? 0 square minus 5 square divided by 2 into negative 10. Yes. So it is much easier now. S is equal to 0 square means obviously 0 and negative 5 square is negative 25 divided by 2 into minus 10 is negative 20, right? Negative 20. So negative 25 divided by negative 20, if you do it, we'll get the answer as, yes, negative and negative will get cancelled, and 25 by 20, if you do it, you will get the answer as,
5 by 4 and 5 by 4, 1.25.
yes, if you simplify it, you can write it as 5 by 4 because if you can divide the numerator and denominator with 5. So it will be negative 5 divided by negative 4, so it will be 1.25 meter. That is the height, this particular height traveled by the stone, it is 1.25 meter. That is the distance or the height traveled by the stone. So we got the answer. This was the much simpler easier method, right? So by using more numerical problems, by solving more numericals, by practicing more problems, you will have an understanding which equation to use. So in this case, you have seen that we can use s is equal to ut plus half at square. We can use 2s is equal to v square minus u square as well. But when you solve more numericals, you will understand which one is the shortest method. So what is the advantage of it? When you are attending your final exams or annual exams or tests in your school, you can save time. Because in a stipulated amount of time, you will be asked to solve, or you are supposed to finish all the problems, right, by that given time. So for that, so as to reduce the time which you consider, you can do it. You can use such methods, so that you will be consuming a very less amount of time for the tests. Understood, everyone? Got it? Fine. So I hope it is clear for everyone. So let me know, everyone. Did you understand this numerical problem of the stone? I know it was the homework. I know everyone might have done it, but still do let me know if it's clear. Everyone, give me the thumbs up. I don't want anyone sitting over there like this. Give me the thumbs up. Give me the thumbs up response. Keep your hands raised only if you have a query. Or else give me a thumbs up. Let me see. I mean, it's like, sir, I was ready in the beginning to answer and you didn't call my name. Not fair. Amen. Today we can call someone else, right? Ayman, are you listening? Ayman is not happy. So why you didn't call my name? Unmute Ayman. Hi Ayman.
Yes, sir.
Very angry?
No, sir.
You don't seem happy?
No, sir. I was just like playing around.
Okay. I thought you lost an important game today at school.
No, sir. It was a game.
You didn't have a game at all at school?
Oh, no, sir.
Nothing like that. So what do you do in your leisure time after school, or what do you say when you get some leisure time? What are your hobbies?
Sir, I either go out to play or I just sit at home and play sometimes. That's it.
Play which game, which sport?
Yeah, basketball only, sir.
Basketball, very good. So any favorite basketball player?
Stephen Curry.
Stephen Curry, fine. So anyone else, any doubts, queries, concerns regarding this particular question? Did you understand how did we solve this? Any doubts? No, right? Mia sir, can you please take down? Yes. Yes, most of the calculation is a little bit confusing. Where yes, just feel like I did not get the topic. Unmute Niranjan. Niranjan is like, sir, calculation part makes me confused. So what you have to do is, Niranjan, solve more mathematical problems. Like the most difficult part for you is the decimal part, right, Niranjan? Unmute yourself. From your face, I can figure out. You are struggling with the multiplication and division of the decimals, right?
No, sir, it just feels like with most of the equations or something we use in it, just feels confusing. I just don't know where is required or like how which one to use.
Where will we apply the equation, or in which equation will apply the values? So are you confused with that, or you are just confused with the calculation part?
Like most of it, sir. Like when I look at it through the screen, it just feels just.
Understood. So regarding the calculation part, what you can do is to improve yourself, try to solve more decimal calculations, decimal multiplication, decimal division and all. And also the thing is, you might be getting confused with the part of cancelling terms. So over here, can you see, instead of 25 by 20 we have written negative 5 by negative 4, right? Isn't it?
Yes, sir.
So what are we doing actually here? You will be confused. How did we get 5 by 4? Do you have an idea?
So like we follow the common factor something like
Common
like,
factors, common multiples we are considering, right? So here 25 divided by 5 and 20 divided by 5. In both the numbers we have a common factor, that is 5. So we are considering. So when we consider the highest common factor, we will get the least simplified fraction of it. Understood?
Yes, sir.
So with respect to 25 and 20, if we are considering 10, is it possible? In 25, 10 is not possible. We can't divide 25 with 10 completely, there will be a remainder. But with respect to 5, we can use it for both. So we'll get the simplified fraction of it, 5 by 4. So that so as to divide 5 and 4, it is easy for you, right? Isn't it?
Yes.
So that's why we take the simplified form of it. Do you remember we have used the conversion formula for 1 kilometer per 1 hour? Do you remember?
Yes, sir.
Which is
I
the fraction
this today and this equation I use the same thing but just got a bit confusing like the way to multiply it, but finally I got it.
Finally you got it, right? So for the kilometer per hour value, we'll be multiplying 5 by 18. Got it? So how are we getting 1 kilometer per 1 hour as 5 by 18? 1 kilometer is 1000 meter. 1 hour is 60 minutes. So 60 minutes means how much? 1 minute means how much? 60 seconds, right? So 60 minutes means how much? 16 to 60. So that is equal to 1000 meter divided by 16 to 60 seconds. Since 60 seconds is 1 minute. Clear? So 60 minutes will be 16 to 60. So if you multiply 16 to 60, how much you will get? You will get it as 3600 seconds. So if you divide the numerator and denominator with 200, you will get it as 5 by 18. 1000 divided by 200 is 5. 3600 divided by 200 is 18. So we got the simplified fraction of it. So that is 5 by 18 meter per second. So for the conversion of 1 kilometer per 1 hour, you can use the fraction. 5 by 18 meter per second. Understood, Niranjan?
Yes.
Regarding the calculation part, the best thing which you can do for yourself is practice more numericals and also improve your mathematical part. What you can do for it? Take more decimal multiplications, calculations, and you just randomly take some values, apply in the equations, and try to solve it by yourself. Understood? So that you can get back to the track. And in the meantime, when we are solving something over here, you can ask me. Got it? You can ask, sir, how did we get this 1.25 meter as the final length? Understood? But basic calculations, you have to work on yourself. Imagine, I'm solving all the basic calculations over here. Will we be able to go ahead? No, right? We'll be stuck in the calculation part itself. So you have to work on it. I hope you get it. Understood, Niranjan? Fine.
Yes, sir.
Yes.
Thanks.
Yes. So Chris is so confused, sir. Today, are we going to take graphs? Because in my class, graphs are about over. Please go ahead with graphs. Everyone wants the graphical representation of motion, right? So we are going to discuss the distance time graphs and velocity time graphs. So how many of you who was that? Chris, in your school, how many types of graphs are already done? How many numerical problems or how many questions related to distance time graph or velocity time graph is done in your school, Chris?
Uniform.
Uniform motion, the graph for uniform motion, non-uniform motion. Fine. So is it just the distance time graph or the velocity time graph portion is also done?
Distance, only distance.
Only distance time graph, right? Don't worry. The thing is, over here, when you get the visualized representation of it, you'll have the best graphs out there. You'll have a better clarity over here. So with respect to distance time graph, you'll be confused which particular term to take in the x-axis, which one to take in the y-axis. So Chris, do you know which type of variable we'll consider in the x-axis or y-axis? Here sir is ready over there with distance time graph.
X, we have to like take time and things.
We have to take time in the x-axis or y-axis. What do you think? We'll take time in the. So there comes the confusion. So that is why 90 plus my tuition app is there for you. So Chris, keep it in your mind. In the x-axis, we'll be considering independent variables. We'll be considering all the independent variables in the x-axis and dependent variables in the y-axis. So independent means what? A particular variable which is not concerned about the other variable or the relating other physical quantities, right? So imagine we are considering the term time. So time will keep consumed, right? So time will go ahead all the time. Each and every hour will go ahead. Whatever we do. Imagine you want to stop time. You want it like 8 p.m. all the time. Please don't go ahead with 9 and 10. Is it possible? It doesn't depend on anything, right? It is independent. It's going according to his wish. So it's like, so fine, please don't call me. I'll just run. So over there, we can understand that particular quantity is independent. It is an independent variable. But consider distance or velocity. The distance which we are covering, does it have a finite value? Does it depend on anything? It depends, right? It depends on the amount of time we have. It depends on the distance which we have to cover. Is it possible for Chris to cover the entire distance of the earth according to your wish? No, right? You have some limitations. So obviously it is dependent on any other particular variable. For example, as the time increases, the distance we cover will also increase or decrease, right? With respect to the time which we are consuming, isn't it? Without considering the time, can we cover any particular distance? Obviously, when you're covering a particular distance, time will also come together. Hi, please don't go alone, I'll also come together. So it is obviously dependent. So the physical quantities such as distance or velocities are dependent variables, whereas time is an independent variable. When you consider the graphs, we'll consider the independent variables in the x-axis or the horizontal axis, and we'll consider the dependent variables in the y-axis or the vertical axis. So let's consider graph so that you'll have a better clarity. So Miha sir, can you please show us a graph as an example? Yes, can you please put me in the middle? Yes, go ahead with the next graph. Go ahead with the next one. Yes, can you put me in the middle? Yes. Please make the graph a little bit smaller. So just a second guys, let's check out a graph. So yes, make the graph a little bit smaller. Yes, keep it down, keep it down. Can you please take down the thumb, the name tag? Yes. Put me in the middle, put me in the middle, in the center of the graph. Can you please move the graph to the right? Yes. Yes. Very good. Yes. So guys, over here, can you see the distance and time graph? So what are we doing? We are considering the time in the x-axis and the distance in the y-axis, right? Why can't I consider the time on the y-axis and distance in the x-axis? Why can't we do that? Everyone is confused. Why are we considering dependent variables in the x-axis itself? Yes, Neha, unmute yourself. Neha, please do unmute yourself. So over here you can see that dependent variables in the x-axis and the independent variables. Okay, independent variables in the x-axis and dependent variables in the y-axis. Yes.
I'm not sure of if my answer is correct or not, but I'll still try.
Yes, go for
Is
it.
this because time is a constant thing? Like it is something we know. It's universally, it's that.
Universally there is a
Yeah, we do have
stipulated,
time.
yes, it's not something which goes according to his wish, right? So anyways, the thing is, Neha, when we are considering for example, an infinite value of the independent variable in the x-axis, how will the graph look like? It'll go till the next country. And will I be able to mark the values? No, right? If we are considering any other dependent variables, distance we can cover, right, according to our wish. But even though it is dependent, we'll be covering a particular distance. So this long amount of value, if I am considering in the x-axis or the horizontal axis, will we be able to draw the graphs? Do you remember the shape of the notebooks, the conventional notebooks and textbooks? We do have shorter length at the horizontal plane and longer length at the vertical plane. So if you consider it the other way, the dependent variables will go according to their wish, so to the next country. So not possible. And over here, if you think logically, independent variables should be considered in the x-axis, and dependent variables should be considered in the y-axis. So for example, over here you can see that distance is considered in the y-axis and the time is considered in the x-axis. So over here you can see the change in the values. So initially, time is given in seconds. So initially when the object is covering 2 seconds, so if the object is consuming 2 seconds, it's covering a particular distance less than 5 meters, right? Distance is given in meters. So it is covering a distance less than 5 meters. So it goes on like that. But the time value, even if it's an independent variable, it has a finite value. So it won't be going to the next country. So we can define it properly. And with respect to the dependent variables in the y-axis, over here we can consume more space, right? So we can mark it properly. Imagine in the other way, will not have standardized way to mark the graph or mark the values, right? So as a standardized thing, always don't forget time in the x-axis or the independent variables in the x-axis, and always. So consider, for example, when we are considering acceleration or velocity, we will consider the units like meter per second and meter per second square, right? I told you, when you're getting the values in some other units, when it's jumbled in some questions, what you have to do? You have to take the standardized value of it. So what you'll be doing? You'll be considering meter per second or meter per second square. In the case of acceleration, we will consider meter per second square. In the case of velocity, we will consider meter per second. So always we will be considering a standardized units for it. That is the SI unit, International Standardized Unit. So over here, we are considering the independent variables in the x-axis and the dependent variable in the y-axis. So please don't forget it. So generally you know that independent variable, as an example, we can consider time. So always we will be learning velocity time graph, distance time graph, or speed and time graph. In all the cases, time will be there. So our beloved time will be staying in the time x-axis itself or the horizontal axis itself. And in some numerical questions, there will be questions like, consider the value of the time axis as, or consider the graph is a straight line parallel to the time axis. So we can understand What is this straight line parallel to the time axis? Which means it is a straight line parallel to the x-axis. Got it, everyone? Nod your head, everyone. If you got the concept, nod your head like a puppet. Yes, sir, we got it. If you didn't get it, raise your hand. Fine. So, Abid, what's your doubt? Go for it.
Distance is in the x and
Why? Distance is in the y-axis.
Okay. So it is represented as distance by time or something.
Yes, distance in the y-axis and time in the x-axis. Yes.
Is it like represented as the formula by time?
Is it represented?
Is it represented as speed formula, distance by time?
Yes, it is represented as yes d by t, distance by time formula. Yes.
Okay.
Yes. It is the distance time graph or d by t graph. Fine. So anyone else, any doubts? No queries, right? You got it, right? Fine. No hand raises, right, Shweta ma'am? Fine. So yes, Mihasa, you can take down the graph. So I hope you know this is a graph for uniform or non-uniform motion. We'll check it out. Yes, Mihasa, take down the graph. So you have understood, right? What is a distance time graph? The basic one. Fine. Then we'll check out the different types of graphs with respect to the distance time graph. So in the distance time graph which you have seen, the graph distance is taken on the y-axis and the time is taken on the x-axis. Please do note it down. And also please do add independent variable in the x-axis, independent variable in the x-axis and dependent variable in the y-axis. Please don't forget to do it. Dependent variable in the y-axis and independent variable in the x-axis. Yes, Rishikesh, unmute yourself. Rishikesh has some query. Go for it.
Sir, in this graph, in this video, that we learned in grade 8 introduction to graphs, it looks like
Exactly. You guys have learned this graph in grade 8 mathematics. That is chapter introduction to graphs. Yes, I do remember. Fine. Thanks for sharing, Rishikesh. Rishikesh is sharing.
Yes. Sir, it's because that didn't learn in the graphical representation of motion. We didn't learn in school.
Okay, you didn't learn this particular topic in school, right? Don't worry.
Yeah.
So when this particular topic comes in your school, no, you'll be the smartest in your classroom. Since you'll be like, yeah, I have learned this already with 90 plus my tuition app, right? Yes, Rishikesh.
In school, acceleration deeds.
Acceleration? Okay, currently the topic acceleration is going on. Fine, fair enough. So yes. Chris, any doubts? Okay, are you listening to something, Chris? I can see that your head is moving like yes, sir. Nothing, right? I feel like you are listening to some rap song or something. No, right? Fine. So please do note it down, guys. In the graph, distance is taken on the y-axis and the time is taken on the x-axis. Yes, Mihar sir, can you please show them a sample graph? Next one. Next one. Yes, the first one. Go for the first one. Yes, can you please minimize it? So guys, I hope you have noted it down. Please do draw a sample graph as well. Yes, I'll just rub it off. Fine. Yes, sir, can you please minimize it and keep it a little bit down? Yes. Minimize the size. Yes. Minimize it a little bit down, a little bit smaller. Yes. So guys, please do draw it in your notebook as an example graph of distance and time graph. So we are considering the time in the x-axis and the distance in the y-axis. Can you please make it a little bit smaller? Yes, sir. I know I have to write x and y. I hope you understand. Unmute Neha. Little bit smaller. Yes. Still you can see the values, right? Yes,
Yeah.
Neha, you have a doubt. Should I draw it in a graph book? No, fair enough. You can draw it down in a notebook itself. In mathematics, when you're discussing the introduction to graphs, introduction to graph is in grade 8 grade, right? But anyways, if it's there in your mathematics subject, what you have to do? Take a graph paper and draw it. And for exams, for your final or annual exams, you'll be asked to draw it in a graph paper. So as of now, for the time being, you can note it down in your notebook itself. Fair enough.
Okay.
Got it?
Thank you, sir.
Fine. So guys, over here is the y-axis, and over here we'll consider the x-axis. Over here we'll consider the x-axis, and over here we'll consider the y-axis. Here sir and Shweta ma'am is like, if we make the graph a little bit smaller, no, they won't be able to see it. So concerned about our students. So please don't make the graph smaller, students won't be able to see it. You guys can see it properly, right? Make happy faces if you can see it properly. If you can't see it, make weird faces. Sir, very tough. Please remove the graph. Fine. Abid, you still have a query or forward to lower your hands? Okay, unmute Abid. Yes, Abid, go ahead. What's your doubt?
Sir, is there acceleration time graph?
This is distance time graph. No, there is no acceleration time graph. There will be velocity time graph. So when you find out the change in velocity, its slope will give the acceleration. Understood? So we'll learn about it. Don't worry. We'll go ahead with that topic. So when you learn the velocity time graph, you'll have an understanding of it. Yes. So unmute Mitesh. Hi Mitesh.
Hi, sir.
Yes Mitesh, what's your doubt?
Sir, this figure is uniform, right?
Yes, this is the graph for uniform motion. Since with respect to time, the distance is increasing. Yes, come again.
So the last one you showed before the distance time graph was the non-uniform.
That was for non-uniform motion. Why? Since it was a curved line.
This is the straight line.
This is a straight line, that was a curved line. So for curved line, it will be non-uniform motion for sure. Fine. We'll go ahead with it. Thanks for sharing, Mitesh. So guys, once you are done drawing the graph, give me a thumbs up. So this dotted lines is just the representation that this particular graph gives the uniform values. When we are considering the time, when we are considering the distance, it gives uniform values. That is, with respect to the increase in distance, the time is also increasing, or with respect to the time consumed, the distance is also increased. So independent variable is time. So we'll consider the time first. With respect to the increase in time, the distance covered will also increase accordingly. So it is proportional. So over here we can see the graph of uniform motion, that is distance time graph. Yes. Unmute. Who is that? Mom? Ishan, right? Yes, Ishan, can you please unmute yourself? Yes.
Yes, sir.
Before we go, who is disturbing you in the background?
That's my brother.
That's my brother. Ishan is like, please stay silent over here. I'm in a session. So is he disturbing you, or you are friendly with him? You guys don't fight or what?
No, sir, he'll just walk in back.
He'll just walk over there. He won't disturb me. Very good, brother. You're lucky. Fine. So Ishan, what's your doubt? Go for it.
So, like you said before, when there's a line parallel to the x-axis.
When there is a line parallel to the x-axis, yes.
Then
When there is a line parallel to the x-axis, okay. Imagine we are considering a particular graph. Yes. So
the object is at rest, right?
when there is a line parallel to the x-axis in the distance time graph, the object will be at rest or in motion?
Rest, sir.
The object will obviously be at rest. We'll discuss it, don't worry. The object will be at rest. Why? When we are considering a straight line with respect to time and distance, the time is increasing for sure, but the particular object is not covering any particular values. So 0, 10, 20, imagine it will be staying in 10 itself. So no distance is covered, the object is at rest. Object is like stable, idle, static. Understood? So when there is a line which is parallel to the x-axis or the time axis, the object will be at rest. So we'll discuss it, don't worry. Can we go ahead? Everyone done with it? So I hope everyone is done with it. So yes, distance time graph for uniform speed or uniform motion. You have already drawn it. So please do mark in your notebook. You don't have to draw it again. Please do mark in the bottom part of this graph. Graph for uniform speed or uniform motion. Distance time graph. So guys, this particular question was asked. Question regarding the distance time graph for uniform speed or uniform motion was asked in Cbse 2016. It is an important topic. You will get questions related to this. So imagine, it's 5-6 years ago this question was there. So there are chances for this particular question to come in this year as well. Unmute Abhineet. Hi Abhineet, what's your doubt? Go for it. Yes Abhineet.
So is it for distance time graph the equation is t2 minus t1 by s2 minus s1?
Yes, we'll consider t2 minus t1 by s2 minus s1. So slope of the distance time graph will give the velocity or the speed. Okay. So we'll consider the distance or the displacement with respect to time. Understood?
Okay.
So generally the distance time graph, the slope of it will give the velocity.
Okay.
Yes. So can we go ahead guys? I hope you have drawn it already. So please do mark it as uniform speed. So when an object travels equal distances in equal intervals of time, it moves with uniform speed. You know what is uniform motion? I hope you do remember. So yes, Mihar sir, can you please take down the graph? Yes. So when an object travels equal distances in equal intervals of time, it moves with uniform speed. For uniform speed, a graph of distance travel against time is a straight line. In the graph which you have seen here, you might have seen that we are getting the graph as a straight line, right? So it's a straight line. So this is my artistic skills. It is supposed to be straight. So over here, you have to consider the distance time graph as a straight line for uniform speed or uniform motion. An object travels or covers equal distances in equal intervals of time, which means with respect to the time consumed, they're covering equal distances in equal intervals of time. So the graph of it will be a straight line. Please don't forget, you will get 1 mark questions like this. For uniform speed, a graph of distance travel against time is dash. So what you'll write as the answer? You'll write zigzag graph. So how many marks you will get? You will get under or 0. Okay. So what you'll be doing? You'll be writing straight line. Please don't write we'll get some frog jump graph or something like this. Obviously, you'll get a straight line. Please don't forget it. Everyone done? Note it down, it's important. You'll get questions related to this. It's important. Please do note it down real quick. When an object travels equal distances in equal intervals of time with uniform speed. For uniform speed, a graph of distance travel against time is a straight line. Any doubts, queries, concerns? No, right? Fine. So unmute Mehrab. Mehrab on top. So Mehrab, are you drawing the graph?
So I was doing it, but then you changed it.
Yeah, okay, Mehrab is like, sir, I was about to draw since you changed the slide, I'm not drawing it. I can see that, Mehrab. I told you, if you have some concerns, you can raise your hands and ask me.
I did half.
You can tell me, sir, I didn't note it down. Can you please show the graph again? Why you didn't ask me, Mehrab?
I was like, first I'll finish this, then I'll ask sir.
Okay, first you will finish this, and when I go to the last topic of this chapter, you will ask, sir, in uniform speed we had a graph, right? So can you show me? So what I'll show? No, I'll show you some egg or some car over here. I'll not show you the graph. Understood? One final warning. If you have such concerns, please do ask. Otherwise, you can sit in one waiting room. So over there, you can't listen to the class, but you can join the Zoom and sit over there. Got it? So if you don't want to sit in the waiting room, you're supposed to ask. Okay? Yeah. And I don't want you to sit over there like this. When I'm teaching, when I'm asking you to write it down, you're supposed to write it down. Got it, Mehrab? Give me a thumbs up. Fine. Anyone else? Any queries?
Yes, sir.
Yes. Yes. Nirmay. Yes. Nirmay, what do you want to share? Sir, how the uniform speed shows? Yes. Go ahead, Nirmay. What do you want to share?
Sir, like I was about to show how the graph of a non-uniform motions.
You are about to show the graph of a non-uniform motion. Fine. So, yes. Before you show it, Mia sir will be showing us an animation for non-uniform motion. Then we'll check out how we can draw the graph of it. Yes, Mia sir, can you please show an animation of a non-uniform motion? Yes, any bus or car or any vehicle. Keep it ready. Yes. Now this one. Yes, we'll show that. Yes. Please play it. So unmute Nirmay. Nirmay, what do you think? This particular vehicle moves in uniform motion or non-uniform motion? Initially, it goes in a normal road, then it goes to the jungle. Actually, they are in a wildlife sanctuary, I guess. They are going for a jungle safari, I guess. Fine. So Nirmay, what do you think? They are moving in uniform motion or non-uniform motion?
Sir, first when they start the car, when the start of the slide, it shows that car is going really fast, and then it's closing the.
Then it slows down. So in the jungle, they are slowing down, and the normal roads they were going a little bit faster, right? Can you see? But if you are only considering this normal roads, they are moving in uniform motion. And if you are considering only the case of the jungle, they are moving in uniform motion. But if you consider it as a whole from the beginning, initially was having a particular speed, and it is changing. End of the day, at the jungle they are reducing the speed, so it is not moving in uniform speed or uniform motion. Got it? And consider this as the example of non-uniform motion. Then how will we draw the graph if the object is covering unequal amount of distances in equal amount of time? So we are considering what we say. We are considering each particular time as 10 minutes, 10 minutes, 10 minutes. Okay, we are considering 10 minutes, 10 minutes, and 10 minutes. How will we get the graph of it with respect to the time? Yes, Mia sir, can you please remove the animation? Yes. So over here, consider the distance time graph and imagine we are considering different random intervals. So guys, why I am drawing this graph not for you to copy. This is how you learn to draw a graph. This is how you learn to draw a graph. If I show a ready-made graph over here, no, what you'll do, you'll just take a pen and pencil and copy it. No, you have to learn how to draw a graph. So we are considering a particular time interval. So it is supposed to be equal intervals. Don't draw like this. So over here I have some special tricks to draw like this. Please don't copy it. So over here we are considering the distance and time, and with respect to that, let's mark it as time in minute. Okay, so don't forget to mark in which unit we are considering the time. So time in minute. In minutes we are considering the time. So 10, 20, 30, 40. And distance, let's consider it in meters. So distance I am considering in meters. Okay, so I'll consider it as 10, 20, 30, 40 itself. So how will we draw the graph, Nirmay? Will it be a straight line like this? Happy with respect to the distance time consumed, it will cover same amount of distance. Nirmay, Shweta ma'am doesn't want to unmute Nirmay, I guess, making faces.
Sir,
yes, Nirmay.
it's not like this. Sir, it goes like a curve.
It goes like a curve. It won't be a straight line like this. Sanjit, if you have raised your hands to say, sir, actually the line is not straight. I hope you understand. I'm not using a ruler over here. So I'm just drawing a random line. Yes, I know, Sanjit. So over here, we'll get a curved line, right, Nirmay? So we can draw like this, or else, how will we draw? Just consider
Sir,
the graph like
from
this.
0 to 10 and 10.
Yes, so we can consider it like this. So initially it was having a particular speed, right? Later on it was slowing down. So it'll go the other way. It'll go the other way. Initially it was covering a particular distance. Then it slows down. So it'll go like this. That's true. So anyways, are we getting a straight line over here? It'll be a curved line, right? Fine. So we were about to share this, right, Nirmay?
Yes, sir.
Fine. Thanks for sharing it, Nirmay. Yes, Sanjit, what's your doubt? Go for it real quick.
Not doubt, sir. I just wanted to tell this.
You just want to say that in the case of non-uniform speed or non-uniform motion, we'll have a curved graph, right? Yes.
Uniform motion will be straight.
It'll be a straight line, or for uniform speed, it'll be a straight line as we have checked out like this. So please don't forget it. Fine. So yes, Mia sir. The slope of the distance time graph gives the velocity of a body. Because when we are considering the Mia sir, can you please take down the name tag? Yes. The slope of the distance time graph gives velocity of a body. You can see that why the slope of the distance time graph will give the velocity. We know that velocity is the displacement with respect to time, right? Velocity is the displacement with respect to time. So obviously, when the object is covering a particular distance with respect to time, will be displaced from one point to the other. Got it? So ideally, conventionally, it is velocity. The slope of the distance time graph is velocity. But theoretically, if you consider, we can name it as speed as well. But still, if there is a question of, if there is a particular ideal case, conventional case, what is the slope of the distance time graph gives? You have to answer it as velocity. Because conventionally, in the case of the distance covered with respect to time, there will be displacement, right? The object will be displaced from one point to the other. So the slope of this distance time graph, this is the slope, right? The slope of this distance time graph will give the velocity. There is the distance covered with respect to time, or the object displaced with respect to time. That is the difference between speed and velocity, right? Yes. Unmute Neha. Neha, in such general cases, speed and velocity we will consider it as the same, similar physical quantity. Got it? This is the general case when we are drawing a graph of the distance covered by an object with respect to time. When the object is covering a particular distance, over there, it'll have the same amount of displacement, right? Only if it's covering some random path. In the case of non-uniform motion, it will not be applicable, right? It'll be confused. But in general case, conventionally, we'll consider the slope of the distance time graph as velocity. And yes, what's your doubt?
Yes, so I was asking if in MCQs there's a question, what does the slope of the distance time graph give us? And there is two options, velocity and speed. So what do we, velocity?
Yes, go for velocity. Because when the, yes, but speed also gives the distance with respect to time, right? So that is why I said, generally, for example, in the graph, what will be representing? What will be representing in a distance time graph? Conventionally, we will be representing the distance covered by an object with respect to time, right? So initially the object is over here. So consider this as Neha as the object. Neha is moving from a particular position to another position. So at the end of the day, Neha is over here. So is the distance covered by Neha is equal to displacement?
Yeah,
Distance is equal to displacement. Got it? So generally when we are considering it in the graph, the distance covered will be equal to the displacement. And we know that the physical quantity velocity is equal to displacement by time. So we'll give some priority to velocity. So it'll be like, yeah, velocity.
Sir,
You take the accolade.
I turned off my camera for a second. That's because like my brother is here. Just a second.
Fine. So that's okay. Let me know, did you understand the concept? Did you understand why do we say generally, conventionally, the slope of the distance time graph gives velocity? Understood?
Yes, sir.
Yeah. Theoretically, if you ask me, you can answer it as speed or velocity both. Got it?
Yeah, is there something called displacement time graph?
Displacement time graph, what we say, theoretically you can consider, but generally, for example, if you ask me two types of graphs, we will consider only the distance time graph and velocity time graph. We won't be drawing a displacement time graph. Why? Because when we are drawing the distance time graph, no, the object will displace a particular distance. So the object, if it's moving from a particular position to the other position, so it will be having a particular displacement. So it is not conventionally required. Understood? For all the things, we'll have an ideal case, right? So ideally, we won't be considering the displacement time graph. Understood? And theoretically, if you ask me, you can draw it. Got it?
Yes, sir.
Yes. So I hope you guys had a clarity. If there is a question, what is the slope of the distance time graph gives? It is velocity for sure. Don't get confused with it. Done, everyone? Done, everyone? Promise was asking, sir, can you show the graph? This is the same type of graph. Yes. Who was that? Mohammed Shaheem, right? Yes, Mohammed Shaheem. Shaheem.
So it means that what do you say? When we try to calculate it, it will be the same as the velocity.
Yes, exactly. Because in the case of such graphs, obviously the distance covered by the graph will be the displacement of it. Got it?
So even in non-uniform motion.
Yes, in non-uniform motion also, we are not considering the path, right? We are considering the distance covered by it with respect to time. So when we are getting the graph, we don't know which path the object covered. We don't know the object took a zigzag path or a straight path. So did you see in the animation, the object, the car was moving in a straight path itself. And still it was in non-uniform motion. So it can be the distance as well as displacement. Because there is no other shortest path. There is a difference between distance and displacement, right? Whereas displacement is the shortest path and distance is the path covered by the object. Understood? So in the graph, this physical quantity, distance and displacement comes together. So we'll consider it as displacement by time or velocity. Or over here, when we're considering the distance time graph, it is the distance displaced by the object. The object is moving from a particular position to the other position, right? So it is velocity. Understood, Shaheen?
So would the velocity time graph, wouldn't it be same as the distance time graph?
No, velocity time graph. You know what is change in velocity gives? What is change in velocity with respect to time?
Displacement?
No. Velocity is displacement with respect to time. Change in velocity with respect to time.
Acceleration.
Acceleration. So when we learn about the velocity time graph, we'll understand.
So velocity time graph is acceleration.
Yes, velocity time graph will give acceleration and distance time graph will give velocity. Now clear with the concept, Shaheen?
Yeah, understood.
Yeah, fine. Thank you. So guys, distance time graph for a non-uniform speed. So as an example, we'll consider non-uniform speed. For non-uniform speed, we'll consider free fall. I hope you have learned about free fall. So when we are dropping an object without any external force, so that is free fall. That is if an object is falling with respect to the acceleration due to gravity, that is free fall. So in that case, we'll have non-uniform speed, right? In case of free fall, we'll have non-uniform speed. Because it'll have particular acceleration, there is an acceleration due to gravity, so speed is increasing, is non-uniform. Acceleration will be constant, it will be uniform acceleration, but speed will be non-uniform. In that case, we'll have a graph like this. Please do note it down.
Sir, Mehrab couldn't complete.
Mehrab couldn't complete the previous slide. Mehrab, unmute yourself. Mehrab, this one?
So, before that, I still haven't.
This one?
I couldn't complete this.
Yes.
So, but I still have a doubt on that.
This one?
Yeah.
Yeah, what's your doubt?
Sir, like you were explaining me like that acceleration and all, I didn't get it.
We'll go ahead with it. With respect to velocity time graph, acceleration. We are yet to go ahead with velocity time graph.
So what's the like T down one, like T1?
T1, T2, okay, that is the time. We are considering two time intervals, time interval 1, time interval 2. So regarding this slope or regarding the slope of this or with respect to values, when we solve some numericals, you will understand. Got it, Mehrab? So as of now, please do keep it in your mind, T1 and T2 are the time intervals, time interval 1, time interval 2. And the distance covered S1 and the distance covered S2. That is, we are considering two values each. The time axis and the distance axis. Understood?
So it's important to mark this like in the question.
No. Yes, in the question if it's there you have to mark it, but over here when you're drawing the uniform graph for uniform motion or uniform speed, it is not mandatory to mark these values. So this is a general graph. Yes, but what you have to do, you're supposed to draw a straight line itself. Don't draw curved lines. This is for uniform speed or uniform motion. So we have to consider a straight line itself. Why? Because it is covering equal distance in equal time, equal amount of time. Got it, Mehrab? Yes. So guys, please do note it down, distance time graph for non-uniform motion or non-uniform speed. Real quick. So regarding the slope or regarding the values of velocity time graph or acceleration, we'll do it, don't worry. Was that Mohammed? Mohammed Sheikh, where are you? Let me know if you have any concerns. I can just see your chair over there. Hi sir, I have just left my chair to interact with you. You can communicate, you can ask questions to the chair. I left the chat. Yes, Sheikh. Fine. Sheikh will come back, or he has some emergency, I guess. Anyways. So guys, done with it. And don't be confused, okay, which value will give 2, 4, 6, 8, 10, 12, 5, 10. In the y-axis or the distance axis also you can mark it as 2, 4, 6, 8. You can consider any random values, but the graph should be a curved line. It should be a non-uniform motion. It should be a graph for non-uniform speed. So it should be a curved line. Yes, who was it?
Good morning, sir.
Yes, Mohammed Sheikh, where were you?
Yes, sir, I went to the washroom.
Okay, you went to the washroom. So, did you inform the chat box? Sir, I need a break. I just want to go to the washroom. Okay, so Sheikh was like, sir, I was about to run. Hope you understand. Fine. So, Mohammed Sheikh, did you understand the concepts of graphical representation?
Yes, sir, I've been writing it down for the past 2
Past 2 hours. The class has covered. Class was about. Yes, come again.
I've been writing, sir.
Okay, we have covered only 1 hour 50 minutes, you can say. But how come you have been watching the session for 2 hours? I don't understand that particular concept.
Sir, sarcasm, because I love.
Okay. Sheikh is like, I'm so sarcastic. So I appreciate that. But if you keep dropping sarcasms, no, hopefully you'll be sitting in the waiting room. Got it, Sheikh?
No, sir. Sorry, sir.
Yes, fine. Yes. So Sheikh is like, sir, please don't put me in the waiting room. Let me get the concepts. Fine. Please do.
Sir, I love to. Sir, I love you and the physics. Sir, you have Instagram?
No. I won't be sharing it over here.
No, sir. Share it over here.
No. Not possible. So first you learn the concepts. Get me the maximum marks. Reflect, not just in marks. Get me the concepts. Show me that, yes sir, I have learned your concepts. Then I'll share it to you. Don't worry.
Okay, sir. Sir, you can send it in the personal chat box.
Not at all possible. I won't be sharing it. Fine. Shweta is thinking, should I mute him or not?
Sir, that makes me very sad and depressed.
Okay. You can go ahead with it. I won't be sharing it anyways. I want you to learn the concepts first. Then we'll go ahead with it. Yes.
Yes, sir. I'm very sad, sir. Thank you.
Okay. Fine. So guys, done with it. Done with the graph of non-uniform speed. Yes. Neha, done? Neha is showing, sir, I'm done with it. Fine. So guys, should we go ahead with velocity time graph? No, right? So let me check out some questions. What is the nature of the distance time graph for uniform and non-uniform motion of an object? For uniform motion, it'll be a straight line. For uniform motion or uniform speed, it'll be a straight line. For non-uniform motion, it'll be a curved line. For non-uniform motion, it'll be a curved line. For uniform motion, it'll be a straight line. You know the answer, right? Fine. Then for the object at rest, how will we get the graph? The graph will be parallel to the x-axis. The distance time graph will be parallel to the x-axis in the case of an object at rest. So this is how you will have the graph for an object at rest if the graph of it is parallel to the x-axis. Yes, some of you are concerned with the velocity time graph. Don't worry, we'll discuss about it the next session. So till now we are covering the portions regarding the distance time graph. We'll discuss about the velocity time graph in the next session. Yes, well, please do check out Shweta ma'am. Yes, in the chat box, whose message is it? Is this
This one.
correct and all?
Nirmay.
Nirmay. Nirmay wants to discuss something regarding velocity time graph, right, Nirmay?
Yes, sir.
Yes. I won't be discussing it in detail. If it's something serious, you can go ahead. Sir, I want to know the answer right away. Go ahead.
Sir, no, sir. I already put it in chat also.
Okay, you want to know, Shweta ma'am, can you please pan it down?
Yeah.
Yes, velocity time graph, it is displacement by time. Is of velocity. No. Velocity time graph is not displacement by time. It is actually change in velocity with respect to time.
Oh, okay, sir.
Yeah, velocity will be changing, right? If you are considering the values of velocity, so there is change in velocity with respect to time. And if you ask me what is s, s is the distance or displacement. The distance or displacement with respect to time is termed as s. So guys, draw the graph for the object at rest. Distance time graph for an object at rest. You are supposed to know this down.
Previous slide.
Niranjan, right? Niranjan always wants to see the
No.
previous slide.
Nidal.
Nidal.
Yes.
Nidal, ready with it? Can I go ahead? Give me a thumbs up. Nidal, where is Nidal? Raise your hand or give me a thumbs up.
Yes.
Fine. So please draw the graph for the object at rest as well. Done, right? I hope it's done. Easy graph. Distance on the y-axis, time in the x-axis, and the line which is parallel to the x-axis. Why? Over here, imagine 10, 20, 30, 40, and we are considering the distance in kilometers. Imagine, kilometers we are considering. Just a second, guys. So consider, we are considering the distance in terms of kilometers. So for that, what will happen? At this particular point, that is at 20 kilometers, the object is at rest. It is not covering any particular distance. The graph is not increasing. It is standing in the same position. But it is consuming time. It is consuming a particular amount of time. The time is moving. Time will not stay stuck over there. Obviously, the time will go ahead. So it is consuming time, but is not covering any particular distance, which means that the object is at rest. Understood, everyone? Clear? Fine. So what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Who will answer me? Some of you is like, sir, we'll go ahead with the quiz time. So Shubham wants to answer, but I won't reveal the answer. Everyone knows the answer, right? Yes, Shubham, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? The object will be?
Sir, it will be at rest because it's a straight line and it's parallel to the time.
If it's a straight line parallel to the time axis, the object will be at rest. Yes, very good, very good. Thanks for sharing, Shubham. Fine, the object is at rest. So velocity time graphs, we will discuss it in the next session so that you will have a better clarity. So as of now, please do focus on the distance time graphs. And some basic questions will be there in the exam time. So let's check it out. So first submit your responses real quick. 2-3 minutes is fair enough, right? Submit your responses. Let me see. Yes, very good. Who is sharing that? It's because the time increases.
Samuel.
Samuel is sharing. Yes, in the case of object at rest, we will get a straight line because the time increases, but the distance remains the same. Exactly. Distance will be the same, right? But the time will be increasing. Obviously, it will be consuming a time. It will not be consuming the distance, or it will not be covering a particular distance since the object is at rest. So it's a straight line parallel to the x-axis. So now you will feel like the exam questions are very easy. You will get the easiest 5 questions. Easiest 5 questions. So let me know once you're done with it. Once you're done with it, please do let me know. Yes, questions questions are very easy. Some of you are sharing, sir, easy questions. I got 10 on 10. How many of you got 10 on 10? Wave your hands to the camera. Sir, I got 10 on 10. How many of you got 10 on 10? Everyone is waving, sir. Easiest questions. I got 10 on 10. So in this particular exam, now those who scored 8, 6 and all, I'm noting your names. If you got 6, 8 and all, if you got a particular mark less than 10, no, it means that you are not focusing in the session. Yes. Yes, yes. Is it necessary that the unit has to be written for the time and distance? It's mandatory. Who was that? Samuel, it's mandatory to write values for time and distance. Time, the standardized unit or the SI unit for time is seconds, so you can mention it in seconds. The distance, the SI unit is meters, so you can mention it in meters. So some of you is sharing, sir, I don't know where I got wrong. I got 8 on 10. We'll check it. We'll check the answer so that you will get to know which one was the right answer. So I'll be just sharing the right answer. I'll not be going for the options. I'll not be showing the options. I'll just share the right answer. So we will get to know which one was the right answer. So those who didn't get the link yet, it's not the exam Google form link in the chat box. You'll have an exam tab on the app interface or the web page interface itself. When you log into the 9+ hybrid live tuition link, you'll have 2 tabs. One is for the Zoom link and the other one is for the exam. Can we go ahead? Fine. So in the distance time graph, distance is taken on the x-axis and the time is taken on the y-axis. Is this statement true or false? Is this statement true or false? What do you think, guys? True or false? Distance in the x-axis and time is taken on the y-axis. What do you think? Who will answer? So if it's false, everyone give me a thumbs down. If it's true, give me a thumbs up. Sir, true, sir. Distance always on the x-axis and time in the y-axis. Not at all, right? Time will be in the x-axis and distance will be in the y-axis. So the statement is false. Is false. Fine. For uniform speed, a graph of distance traveled against time is... Time is what Neha is showing like this, sir, a curved line. Neha is like, I actually showed a straight line. So for the graph of distance travel against time, it'll be, do you remember the graph? Is a straight line. It'll go until this. Hope it won't hit on 90+ my tuition line. So obviously, it is a straight line. Everyone knows the answer, I guess. For uniform speed, a graph of distance travel against time is a straight line. So the first option was right answer. Now, slope of the distance time graph gives dash of a body. Slope of the distance time graph gives. Now Neha is smiling. Yes, sir. I asked the same doubt, so I am sure about it. If there is a question, what will the slope of the distance time graph give? So Sneha answered velocity, I guess. Neha answered velocity, right? Durgesh, what did you answer? Durgesh wants to answer something. Durgesh, unmute Durgesh just below Neha.
Yeah.
Durgesh have hand raised. Durgesh, you answered speed, right?
Yeah, sir, I answered speed.
I told you. Neha asked the same question. If there is a question, conventionally what should we answer? Because speed also comes, right?
Yes.
Distance with respect to time is speed. But conventionally, what you are supposed to answer, slope of the distance time graph will give the velocity of a body. Understood? Yes. Now, distance time graph for non-uniform motion is, how many of you wrote zigzag line? And there was an option. It's better not to draw the graph, right? And there was an option, curved line. Everyone knows it. Everyone is doing some dance moves and all. It's supposed to be curved lines, right? So distance time graph for non-uniform motion is a curved line, isn't it? Now, the distance time graph will be a straight line parallel to the time axis if the object is dash. If the object is dancing, if the object is jogging, you had some random fancy options, right? If the object is going for jogging, how many of you clicked on that? Those who clicked on that, no, I'll give you 0 for the entire exam. Yes, everyone is showing the answer to the camera. Neha, Chris and all. Chris is like, yes, rest. The object is at rest. Some of you are dropping it down the chat box. Yes, obviously the distance time graph will be a straight line parallel to the time axis if the object is at rest. Very good. So yes, anyone else who wants to ask any doubt, queries? Those who want to answer about the exam time, you can lower your hands. Otherwise, I'll assume you have a doubt. Fine. Any doubts, queries, concerns? Yes. So everyone, share your feedback. How well did you understand this particular session? Share your feedback. In which all areas we need to improve? In which all portions we need to improve? What are the things we need to do? We need to work on it. What are the things you like the most? Did you like the animation? Did you like the graphical representation? So which part you like the most? Did you get everything? Are you getting classes well? Is it useful for you? Is the animations beneficial for you? Visualization of it is beneficial. Yes, calculation part, some of you are sharing, sir. Calculation part, we need to work on it. You need to do some basic calculations, right? Yes, some of you are sharing, yes, I love the animation. Understood, tongue twisters. Some of you like tongue twisters. Chris is sharing, sir, graph is very boring. We'll finish the graph part quick, right? We'll finish the topic quick. So, Chris doesn't like the topic graphs, I guess. It's good, I can understand well. The animation was super. Fine. So the session was helpful, right? For everyone? It was good. I like the animation. Yes. You guys make use of the animation well, right? Animations will be very helpful for you guys, I guess. It will give you a better understanding of the concept. Yes. Okay, some of you are sharing in spite of my first class. I like the whole session. Yes. Good class. The graphs are understandable. The session was good. Was fun and understood. Today's portions at the same time. The calculations just, yes. And I understand the Ranjan. Please do work on the basic part. The remaining calculation part, no, don't worry. You can ask me. Sir, I didn't get this calculation part. It's okay. Krisha is asking, yes, sharing was fun, fine. We'll take the session fun and friendly when you guys are learning, when you guys are revising, we can take it ahead. We can have fun, we can chill out in the session, and also alongside we'll learn the concept. If you're not learning, if you're not putting efforts, I'll also be like, yeah, I'll just teach the topic. We won't have fun. If I feel like my students are learning everything, putting some efforts for it, if I'm getting answers, if you are reflecting the concepts, I'll be very happy. I'll be like, yeah, you're learning everything quickly so that we can have fun for some time. Got it?
So someone caught you in the Instagram.
Who is sharing that? Who was that?
That was Helmi.
Helmi Jafar is sharing, sir, I got your Instagram. Yes, okay. Some of you are sharing, yes, sir, I got you on Instagram. Yes, it was fun. Yes. No homeworks today. We'll learn more about the graphs, then we'll solve some numericals related to it so that you'll get more homeworks. So for the time being, what you have to do by the next session, please do revise the concepts which we learned today regarding the distance time graph. What are the things which we have learned? Don't forget to do it. That's all for today. Before we wind up, anything else? No, right? Fine, stay healthy, stay happy. That's all for today. Have good food. Bye bye. Give me a double thumbs up, everyone. Yes, thank you and bye bye.